So hey everyone, in this video we are going to solve the LeetCode problem, that is 2-sum. Alright, so this is one of the most popular LeetCode problems, and it is almost asked in most of the interviews. Okay, so this is a fairly simple problem, but it also challenges the candidates if they are able to solve this problem in the most efficient way. Okay, so in this video I'm going to clearly explain you how you can solve this problem, and also in a very efficient way. All right, so let us see what is the problem states. So this is a problem where we need to return two numbers, where when we add those two numbers it should equal to the target. Okay, so the target is given as 9, so we need to return two numbers that when we add returns is equal to 9. Okay, so you see that these are the two numbers, so 2 plus 7 will result to 9. Okay, so we need to write this in a form of code, and we need to also check for other numbers if they constitute to 9. Okay, so what is the brute force way, or the most simple way to solve this without any efficiency? Okay, so what we do is we initialize two pointers, at I, which is at the 0th index, and j, which is at the first index, and we create nested for loops and make the comparisons. Okay, so first we compare I and j, if there are if we add them will equal to 9. Okay, so in this case it's equaling to 9, but we need to also check for other cases. Okay, so because all problems will not be the same as this. Okay, so after this we increment j. Okay, so we move j to the first index, and this keeps on going until j finishes its iteration, and then we increment I. Okay, so now I goes to the first iteration and j comes back to the original position, so that is one step after I. So this creates nested loops, and the time complexity of nested loops is O of n square. Okay, so which is very bad in performance. So we need to avoid writing such algorithms or solutions which take the time complexity of O of n square. Okay, so we are creating nested loops, and we are recalculating the same values which have already been calculated. Okay, so that is a double work for the machine to perform. So this is the time complexity, and space complexity is just O of 1. Okay, because we are just returning one number and we are just storing that to check if that is equaling to the target. Okay, so let us check how we can solve this in the most efficient way. Okay, so I'll tell you how exactly we can solve this problem in the most efficient way. So we just loop across the array just once. Okay, so we initialize a pointer, let's say I. So the idea behind this trick is to find the complement such that we go to the target, that is 9. Okay, so in the first iteration the value is 2. Okay, so what is the complement such that if I add a number to 2 will give me the target of 9. Okay, so that is 7. Okay, so I just need to create a hash, okay, or an object within my memory. So I will create a hash. Okay, so this can be a simple JavaScript object or any programming language you're using. So I just assign this initially to an empty object, and I just keep on adding the values to it. Okay, so the value will be the key. Okay, so the value, that is the complement. Okay, so the complement of 2 is 7. Okay, which results to 9. So the 7 I need to make that as a key and store the index of the particular iteration of I. Okay, so that is 1. Okay, so this is one value within my hash. Okay, so now I just keep on incrementing I and just find the complement of what is actually there. So now I increment I. Okay, so what is the value when I add to the ith value, that is 7. So that is 7 plus 2. Okay, so 2 is the complement which will result to 9. Okay, and I need to check the value of I if that is there already in our hash. Okay, so if it is not there in our hash, we add that number to the key of the hash and the value to the index of that. Okay, so here the value is 7. Okay, so the number is 7 for the ith iteration. So we check the if it is already there within our hash. Okay, you see that 7 is already there. Okay, so we just need to grab the value of that is 1. Okay, so this is not the value, but this is the index which we need to return at the end of the program. Okay, so once we found if that value is there within our hash, we return that index as well as the current iteration, that index. Okay, so we return, that is index of I is 1, and what is the index of the 7? That is sorry, this should be 0. Okay, so my bad. So we return 0. Okay, so index 1 and 0, that is 2 and 7, when we add those two will give us the result 9. All right, so this is the trick. As we end the program, or if we don't find anything within our hash, we keep on incrementing I until we reach at the end of the array. Okay, so if we don't find any complement which is already present in our hash, we return null. Okay, so what is the time complexity of this technique of using to solve the two sum problem is that is O of n. Okay, since we are just looping across the array just once and not creating any nested for loops, so the time complexity reduces from n square to just n. Okay, so which is the most optimal way of solving this. And the space complexity, this time it is not O of 1, but we saw in the brute force that we are not storing any additional data structure within our program, but here we are storing a hash. Okay, so the space complexity becomes O of n, because the worst case is we can have an hash filled with all the elements within the array. All right, so that is the worst case when it comes to space complexity. So the reason why we are creating a hash is the insertion and removal from any and accessing any element within the hash is O of 1. Okay, so we don't have to again loop like an array. Okay, so that is why the reason we are creating an hash, and by this we can efficiently solve this problem. Okay, so let us now go ahead and try to code this and solve the problem of two sum within LeetCode. So let's get started by creating a hash and set that initially to an empty object. So now we just need to loop across all the elements within the array. So for let I equals 0, I less than array dot length, so I plus plus, and inside this loop we just need to first let us see the current value of the index. So let's set that to a num variable, so that is array at the ith index. So now we just need to find the complement of this particular number. Okay, so let's call that complement and set that equal to target minus num. All right, so once we find the complement, we just check that if that is present in our hash. Okay, so if it is not there in the hash, we add that. And okay, so if it is there in the hash, then we return that along with the current iteration. Okay, the index of that. So let's check if complement in nums. Okay, so this is an in operator which will check if this is actually present within the hash. Okay, so this should be hash, and if it is there in the hash, then we return that along with the current index. So return, then we return in the form of an array, because that's what we are expecting over here as an output. So that is the hash at the complement, and then return the current iteration index. Okay, so once if we don't have within our hash, then we add that to that. Okay, so we say hash at the particular number and set that to I. Okay, so we are storing the value of that as a key and then the index of that as the value. Okay, since values are the things we need to return. Okay, so that sets that, and if it doesn't return anything, so if it comes out of this for loop, so we just need to return null. Okay, so if I try to run this, and yeah, that looks good, and if I submit, let's see our performance, and yeah, so almost 100%. so yeah, so by far I guess this is the best approach to solve this problem. So I hope you have understood this problem, how to solve two sum, and I'm sure that by this you could solve any kind of problem. And yeah, that's it. So let's now move on to the next video. If you have any questions, please let me know in the comments. So I'll see you guys in the next video. So hey everyone, in this video we are going to understand the LeetCode problem. Okay, that is to solve the problem of best time to buy and sell a stock. Okay, so this is one of the most popular LeetCode problems. Okay, and it is most frequently asked, and we just need to return the maximum profit. Okay, so within we'll be given an array. Okay, so which is the best time to buy and sell a stock. Okay, so if I just tell you what is the answer, so you see that if I buy at this particular date, okay, so at buy at 1, and if I sell at 6, so what is my profit? 6 minus 1 is 5. Okay, so I return the maximum profit. Okay, so this is a fairly easy problem, but we just need to solve this in a very efficient way. Okay, so what is the brute force way or the naive way of solving this problem? Okay, usually when people don't apply any techniques, so this is the solution which they come up. So that is, I initialize 2 pointers. So one will be at the first index or the 0th index, and then initialize another pointer at the first index. Okay, so we just loop across every single array. So we create nested loops, okay, and make every single comparison and checking that if this is the maximum price, and we just subtract that from the ith value. Okay, so again we just need to avoid any kind of nested loops, and this results to a time complexity of O of n square, okay, which is terrible. As input keeps growing, your time that will be taken for solving the problem also keeps on expanding. Okay, so this is the approach which you just need to avoid. So by this approach we result to a time complexity of O of n square and space complexity of O of 1. Okay, since we are just returning a number, okay, and we are just keeping track of just the number, right? So this is the approach which we need to avoid. So what is the better way of solving this problem? Okay, so what I can just do is I can keep track of 2 variables. One is the minimum price. Okay, so as we keep on iterating throughout the array, I keep track of the minimum price. Okay, so what is the actual minimum price as we keep moving on? So let's call it min price. Okay, initially it's going to be at the value of the first index, so that is 7, and then we keep another value to track the max profit itself, okay, which we have to return at the end of the code. So let's say max profit, and initially it's going to be 0. Okay, so if it doesn't reach anywhere, like let's say we are getting only negative values, then we just return 0. Okay, so we are not updating the max profit. So now we just need to loop across each and every element within the array by initializing I. Okay, so the minimum price is 7 and max profit is 0. Then we increment I. Okay, so I is at the first index. Now we check is this the minimum price? Okay, so again 1 is less than 7, so we update 7 to 1. Okay, so now this is the minimum price, and then we move on to the next iteration without doing anything. Okay, so once we find, now we are at the second index. Now this is greater than the minimum price. Okay, so now it's the time to calculate the max profit. Okay, so what is the max profit? So we calculate the value of I, that is 5, minus the minimum price, that is 1, and now we just need to make a comparison. So if the max profit of the previous value, which was 0, if that is still less than 4, okay, so if 4 is greater than 0, then we update the value of the max profit to 4. Alright, so now we move on to the next iteration, that is at 3. Okay, so again minimum price is 1, but this is at 3. Okay, so we don't do anything. So now I is at 3, so again we just need to calculate at that the value of I, that is 3, and subtract that to the minimum price. Okay, so this becomes 2, and we need to check if 4 or 2, which is greater. Since 4 is greater, so we remain that to be the same. So then we move on to the next index, that is at index 6. Okay, so 6 is greater than 1, so we don't update the minimum price. So now we calculate the maximum profit. Okay, so we say 6 minus the minimum price, that is 1, and we just check that it is equal to 5. Okay, now we just need to compare that to the previous value of the max profit, so that is 4, and since 5 is greater than 4, we update the maximum profit to be 5. Alright, so this is the approach. Again you keep incrementing, right? So this is 4, so 4 minus 1 is 3. Okay, again 3 is not greater than 5, so we remain that to be 5 itself. Okay, so this is the best approach to solve this problem. And what is the time complexity to solve this? So that is, we are just making one iteration throughout the array, and the time complexity is O of n. And what is the space complexity? Again we are just keeping track of 2 variables. So O of that is 2, which is, we can just say that is O of 1 itself. Okay, so this is the time and space complexity of this. So I know this problem statement itself says that when to buy and sell stock, but the actual problem is to return the maximum profit. Okay, so I don't think the title of this LeetCode problem should be the same. So it should say that return the max value. So anyways, let's go to our code and try to solve this problem. So let's create those two variables, that is for the max profit and for the minimum price. So this is the variable which will be returning at the end of the code, and let's set this initially to 0, and let's set the min price to the first element within this array, and that is prices at 0. Alright, so now let us run a for loop and set the ith value to the first index but not the 0th index, because we have already set the minimum price to the first 0th index. So let us start from the first index, and I is less than the array dot length, so prices dot length. Alright, so inside this loop we are just going to check what is greater, the minimum price or the current value. Okay, so let's check if min price, or we can say if prices at I, that is greater than the min price, then we just want to update the min price to the prices at I. Okay, so we set min price and set that equal to prices at the ith index. So this is the current value, and if that is lesser than that, now we need to make the comparison. Okay, put an else and check. So now we just need to subtract the current value to the minimum price. Okay, and just check that if it is greater than the max profit. So if it is greater than that, then we update that to the particular value, else we just remain that to be the same value. Okay, so we can achieve this using the math operator within JavaScript. So math.max, and we just compare two values, so if, which one is greater. Okay, so we just return that to update the variable max profit. Alright, and let's check which is greater, max profit or the difference between them. So that is prices at I. Okay, so since we already know that this is greater than the minimum price by this if check, and let's do the subtraction, since we don't because we might get a negative value, right? So to the max min price, and let's finally return the max profit. Okay, so everything looks good. So now is the time to test. So I click on run, so it should be less than min price, sorry. Alright, so now we try to rerun, and yeah, so submit. Okay, so yeah, that looks good. So beats 97.94 of the competitors. I guess the best way to solve this problem. So if you have any questions, please let me know. So see you in the next video. So in this problem, we need to move the zeros within a existing array to the end of the array. Okay, so given this array, okay, so it says 0, 1, 0, 3 and 12, and wherever you find 0, you need to push it at the end of the array. Okay, so how would we solve this? Okay, what is the brute force approach? So what would be the non-optimal way of solving this? So again, we create a empty array, okay, and we loop across each and every item within the array, and we see that if that is not equal to 0, okay, so if that is not equal to 0, we add that to the array, and 3, 12, okay, so the length of this new array is 3, and we compare that to the length of the given array, that is 5. So there are two zeros, okay, so that needs to be added, so we add that at the end of the array. Okay, and finally we return this array itself. Okay, so by this we are creating an extra data structure which is an array which takes the space complexity of O of n. Okay, so which is not the most optimal way. There is more better way of solving this, that is by not creating any additional data structure, and by modifying the given array itself, okay, the nums array. So how can we solve this? So what we now do is we initialize 2 pointers, one is I and j, okay, which will start at the starting of the array. Okay, so we are not creating nested for loops, but we are just creating one for loop for the j value, and based on conditions we increment the I value. Okay, so we modify the value of I and j based on two conditions. Okay, so the I value should not equal to j, and j must not equal to 0. Okay, so in this case j is also 0, and I and j are also 0. Okay, so what we just do is we just increment j. Okay, so now j is at the first index. Now we see that j is not equal to 0 and I and j are also not equal. So in this case, what we need to do, we need to update the value of I to the value of j, okay, and make the value of j as 0. Okay, now we increment j and we increment I. Now we see that I and j both are 0. So now we just don't do anything, we just go to the next iteration. So we increment j. Okay, so now I and j are not equal and j is also not equal to 0. Okay, so in this case, what I told, we need to update the value of I to the value of j. Alright, and make j equal to 0. Okay, so now we increment j and increment I. Now we see that j is not equal to 0 and I and j are also not equal. Okay, so now we update the value of I to the value of j, that is 12, and update the value of j back to 0. Okay, so if you see that we have achieved the result that we want. Okay, so we have pushed all the zeros to the end, and we are not creating any additional data structure, and we are keeping all the other elements at the start of the array. Okay, so what is the time complexity of solving this problem? That is O of n. And space complexity, since we are not creating any additional data structure or any arrays, so we can say that O of 1 is our space complexity. Okay, so let us now understand how can we solve this in code. So let's start by initializing the pointer I equal to 0. Okay, so now we are going to run a for loop for the j variable, which will loop all the elements within our nums array. So let j equals 0 and j less than dot length, and increment j. So as I told, we need to make two checks. One, we need to check the value of j, so that should not be equal to 0, and also the index, the pointer I and j should not be equal. Okay, so let's put the first one. Let's say if nums at j does not equal to 0, so inside this we need to make the value of I equal to the value of j. Okay, as I explained. So nums at I equals nums at j. Okay, so now we need to make another check over here, saying that if the index I or the pointer I does not equal to pointer j, then we just need to make the value of j equal to 0. Okay, like this, and finally we just need to increment I. Okay, and finally return the nums array. Okay, so we are just modifying the nums array and just returning it. Okay, alright, so sorry, we just need to increment I after this if block. Okay, so once if I and j are not equal, and we are just setting the value of nums back to 0, and then we just keep doing the same thing. If nums at j is not equal to 0, then we set the value of the ith index, the value of at I equal to the value of j. Okay, so that's what this code is doing. So by the end of the loop, we'll be having all the zeros at the end and all the non-zero values at the start. Okay, so by this, if I just save this and try to run this code, okay, so our answer is accepted. So if I try to submit and see the performance, okay, so almost 80%. Okay, but not the best, but yeah, this is actually an acceptable solution, which beats more than 80% of the competitors. Okay, so this is the solution for move zeros. So now let's move on to the next problem. This is a problem called pivot index, where you will be given an array of numbers. So we need to find out that one index where the values on the left side and the values on the right side are equal. Okay, so for example, you see that this is the pivot index. Okay, so I'm just right away telling you the answer. So the pivot index is 6 because this is the index that is at index 3, where the sum of the left values and sum of the right values are equal. Okay, so the sum on the left is equal to 11, so 1 plus 7 is plus 3 is equal to 11, and the sum on the right side, so 5 plus 6 is also 11. Okay, so this is the index where we need to return at the end of the problem. Okay, so how do we solve this? So the brute force way of solving this problem is, let's say I initialize the value I, and I just need to loop across every single item to find if that is a pivot index. Okay, so what do I mean? So you see that at the first iteration, obviously there is the sum of the left values is 0 and the sum of the right values are more than 0, right? So this is definitely not the pivot index. So we increment I. Okay, so we see the what is the sum on the left side, that is 1, and the sum of the on the right side is obviously greater than 1. So that is the sum on the left and the sum on the right are not equal, so we move the I to the next index. Okay, so now we see what is the sum of the left. Okay, so that is 7 plus 1 is 8, so 8, and the sum on the right side is 6 plus 5 plus 6 is 17. So obviously they are not equal, then we increment I. Okay, so now this is the pivot index where we see the left and the right both are equal to 11. So we return this value. So what is the problem in solving using this approach? So we are recalculating those sum which has already been calculated. So you see that 1 plus 7 was already calculated as 8. Okay, so we are again calculating 1 plus 7 plus 3, which is 11. Okay, so again we are using nested for loops. Okay, so this is one for loop, and again we are putting another for loop to calculate each and every item within the array. Okay, so what is the time complexity? So that is O of n square. Alright, and because we are using both on the left and the right, so it is basically O of n square plus n square, which is again equal to O of n square. Okay, so this is the time complexity, and space complexity is nothing. We are just returning one value, we are just returning the index, so that is O of 1. Alright, so what is the better way of solving this? Okay, so this is all about the brute force way of solving this. So what was the problem that we were facing in the brute force way is by recalculating values. Okay, so by creating nested loops. What is the best way to solve this? So basically we try to calculate the entire sum of the array. Okay, so that would come down to 28. Okay, so if you calculate all the numbers, so once we have calculated the sum, that is 28, we initialize a pointer at the start of the index, and we keep track of a variable called as left sum. So we are calculating the sum on the left of the index. Okay, so initially it's going to be 0. Okay, so now we see at the ith index, so this is the formula. Okay, so the sum, okay, so this sum, that is 28 minus the left sum, the previous value, that is 0, and then the value of the current index, so that is 1. So the left sum is 27. Okay, so now we need to compare the new value of left sum to the old value of that. Okay, so 27 is not equal to 0, so we increment I. Okay, and then keep doing the same process unless we find the left sum, if that the old and the new value, if they are equal. Okay, so that will be the pivot index. So once we increment the value of I, we also need to update the value of left sum. Okay, so that is the sum of the on the left side, so this becomes 1. Okay, so now we need, so this is all checks, okay, which we are making. So now we need to make another check, so let's do the same process. That's 28 minus the left sum, that is 1. Okay, and then we need to subtract the value of I, because this is not the value which is included. Okay, so that is 7, and this comes down to 20, and now we check that 20 is not equal to 1. Okay, so again we increment I and update the value of left sum. Okay, so that is 7 plus 1, 8. Okay, so again we do the same process. So 28 minus left sum, that is 8, and minus the value of I, that is 3. Okay, so this comes down to a value of 17, which is not equal to the value of left sum, that is 8. Okay, so I hope this is not too confusing, so I'm just telling you the easy way to understand this problem. Alright, so let us again increment I, so which I already told you that this is the pivot index. So let's see if this particular process is able to solve this. So again we take 28. Okay, so don't forget to update the left sum, so that is 1 plus 7 plus 3, that is 11. Okay, so what we are just doing is we are not again calculating the sum of this. Okay, what is the previous value? That was 8, right? So we are just adding 3, so that brings us 11. Okay, so 28 minus 11 minus the current value 6. Okay, so that comes down to 11, and which is equal to the value of left sum, that is 11. Okay, so by this we can return saying that this is the index. Okay, so the index is 3. Okay, so then we return the answer as 3. Okay, so this is 0th index, first index, second index, and I is at the third index, so we return 3. So this is the solution for the problem pivot index. So let us see how we can solve this by code. So let us get started by calculating the sum of the entire array. Okay, so I'm going to use the higher order array method called reduce, so which will take in the accumulator and the current value as input parameters, and then we just need to add on those values, okay, for every iteration it makes. So let's say nums.reduce, and the first parameter is the accumulator, and then the second one is the current value. Okay, so I can just call this current like this, and so these are the two input parameters we get. So all we just need to do is add in the accumulator and the current value. Okay, so and then the initial value of the accumulator is 0. Okay, so with that out of our way, let's create a variable called left sum to keep a track of our sum so far we have come across. So let's initialize that to 0, and now let's run a for loop to loop across every item within our array. So let I equal 0, okay. So first thing we need to do is we need to apply the formula and check if it is valid. Okay, so let's put the formula within the if block. So if first is the left sum, as I explained within the explanation, so if that is equal to the sum of the array, and that minus the left sum, the current value of left sum, minus the current value at the ith iteration. Okay, so nums at I. Okay, so if this condition satisfies, we directly return the value of I, which means that that is the pivot index. Okay, so if that is not the thing, then we update the value of left sum, so that plus equals the nums at I. Okay, so we are not calculating values again, so we are just adding the same value again to the left sum. Okay, so we don't have to calculate the values again. So by this we can finally return the value of -1 if it doesn't find a pivot index. Alright, so if I save this and run the code, yeah, so if I submit, let's check the performance. Alright, so 100%. so this is probably the best solution. Okay, so like I hope this is clear. So let's now move on to the next problem. So in this LeetCode problem, we need to remove the duplicates within a given array. Okay, so this is the array which will be given, and you see that there are a lot of duplicates inside this array. So 0 is repeated 2 times, 1 is repeated 3 times, and we just need to return the length of the array which with unique values. Okay, so you see that there are 5 unique values, 0, 1, 2, 3 and 4. So the length of that is 5. Okay, so we need to return that value. Okay, so let us get started on how we can actually do this. So first of all, we need to modify the existing array, and instead of creating a new array. Okay, so that is the brute force approach, where you create a new array and return the length of that, okay, by unique values. Okay, so what we just so we create a new array, okay, and we just loop across each and every item within the array and just check if that is already existing within the array. Okay, so first is 0, and again 0 is occurring, so it is already there in that array, so we skip that iteration and then move on to 1. Okay, and then 1 is already here, okay, for the next iterations, so we just move on, and 2, 3 and 4. Okay, so whenever the we check if that is there already within the array, then we do not add those elements to the array, and we just return finally the length of that. Okay, so 0, 1, 2, 3 and 4. So what is the length? 5. Okay, so the problem in doing this approach is we are creating another array with these unique values. Okay, so we do not want to do that. We can there are ways we can also modify the existing array. Okay, so by this we get the time complexity of O of n and also the space complexity of O of n. Okay, because the worst case is all the elements within the array can be unique. Okay, so this is a brute force approach. So we can slightly do it in a better way. So as I told, we do not want to create a new array, we want to modify the existing array. Okay, so if I can show you this. So what we now do is we initialize two pointers, one is I, okay, and another one is at j. Okay, so j will keep iterating throughout the array, and whenever we find that the value of I and j are equal, then we increment I, okay, and update the I value to the what is the value in the j. Okay, so once we initialize these two pointers, we check the value between these two pointers if they are equal or not. Okay, so now you see that the value of I and j are equal. So what we just do is we don't do anything, we increment j. Okay, so j goes to the next iteration, and now that they are not equal. Okay, so what we now need to do is increment I. Okay, listen carefully, increment I and then update the value of I to the value of j. Right, update the value of I to the value of j. So I becomes 1 because j value is 1, so I update that to 1. Alright, then I increment j. Alright, now we check if I and j are equal. Yes, they are equal, so we don't do anything, we increment j. Okay, so again they are equal, we again increment j. Now they are not equal. Okay, so what I told, we need to increment I and set the value of I to the value of j. So I becomes 2. Alright, and then again increment j. Again I and j are equal. Okay, and then we increment that once again. Now j is 3 and I is 2. So what I told, we need to increment I and update the value of I to the value of j. So this becomes 3. Alright, so again we increment j. Okay, both are 3, again increment j. So now j and I are not equal, so we update the value of I. First we increment I and then update the value of I to the value of j, that is 4. Okay, and then we do not have any elements after that. Okay, so now j is out of range, so the index of I is the final value which we need to return. Okay, so since arrays are 0 based, so we need to increment that by 1. Okay, so we just return I plus 1. Okay, so I is at the 0, 1, 2, 3, 4, fourth index, and we just need to increment that by 1. So the answer is 5. Alright, and also if you want, you can just replace all of these numbers by putting another for loop after I, and then we increment that. Okay, by you can just replace that by underscores. Alright, so this is optional because this is also mentioned within the problem statement. So if you want, you can just do that as well. Okay, so this is the solution how we can remove duplicates within an existing array without creating any extra space. Okay, so what is the time complexity of this? Again, it's still the same as the brute force, so that is O of n. Okay, since we are iterating each and every element within the array, and the space complexity is O of 1. Okay, so this is the approach which we are trying to overcome from the brute force method, where the space complexity was O of n. Okay, so we are not creating any additional data structure within our code. So this is the most efficient way of solving this problem. So let us now understand how can we solve this in code. So let's initialize the pointer, let's call it I and set that to initially to 0. So let's now run a for loop where j is at the first index. So let j is equal to 1 and then j should be less than nums.length. Alright, and then increment j. So inside this for loop, we just want to make the comparison, right? So first we check if the nums at j, if that does not equal to nums at I. Okay, so then we just increment I as I told, and now we just make the value of I to the value of j. Okay, so nums at I should be equal to nums at j. Okay, and we just need to return the index, right? So we just need to return I plus 1 since it starts from 0. We just need to increment 1, so we just need to return the last element, the index of that, so that is I plus 1. Okay, so now if I run, okay, so our test case is pass, and if I submit, okay, so that is 100%. maybe this is the best solution to solve this problem, to remove duplicates from a sorted array. Okay, so yeah, this is the solution. So let us now move ahead to the next problem. So this problem is called as rotate array. Okay, so what do I mean by rotating an array? So you will be given an array of numbers from any number, okay, and another value, that is k. Okay, so k is a value where you need to rotate the array. So what do I mean by rotating the array? So if the k is 3, I just need to shift one position, the last element of the array, backwards 3 times. Okay, so 7 will go at the starting position, then 6, then 5, so 3 times. Okay, so this is the output where the 7 goes first, and then 6, and then 5. Okay, so this happens the k number of times. So k is 3, so if k is 4, then even the 4, okay, will go at the start of the array. Okay, so we are rotating the array, if you see, if this makes sense. Okay, so how we can solve this problem? So let me just erase this, and let's say k is equal to 3. Okay, so what is the brute force way of solving this problem? So I set the value of I. Okay, so I create nested loops, okay, to solve this problem. What I do is I save the last element, that is 7, into a variable, let's say last, and set that equal to 7. And now I just need to shift one position from each element within the array to the next position. Okay, so what do I mean by that? So if 1 is at the index 0, so I need to push that to the index 1. Okay, so 1 comes here, then 2 goes here, it goes all the way until we reach 6, okay, which is at the last index. And now the last element that we saved within the variable, then we put it at the start. Okay, so this is first iteration. Okay, so we are already running a nested loop to shift one position. Again we need to run another loop to until we reach k. Okay, that is 3. Okay, so we need to do the same process 3 times. So now we update this last variable to 6 because 6 is the last element. Okay, and then again we do the same shifting process. Okay, so 7, which was in the 0th index, goes to the first index. So 7, 1, 2 goes all the way up to 5. Okay, and then the 6 that last we had saved goes to the first position within the array. Okay, so this is the second iteration. Okay, and this will be the last iteration, that is for the k, and again we need to do the same thing. Okay, so 5, we store last to 5 and then move 5 to the start. Okay, and then go all the way from 1 to 4. Okay, so 5, 6, 7, 1, 2, 3, 4. Okay, so if you notice that we are creating nested loops, so one is to unshift and one is for the kth iteration. The time complexity of this solution is O of n square. Okay, so which is terrible. And space complexity, we are just creating one variable and we are just modifying the existing array. Okay, so we are not creating any extra variables apart from this last variable. So space complexity becomes O of 1. Okay, so this is the brute force approach, which is we normally need to avoid. So let us understand what is the most efficient way of solving this. So what we now need to do is we need to reverse the entire array. Okay, so to reverse an array, so what we just do is we use the reverse function. Okay, so we will already be creating a function which will reverse certain things. Okay, so we need to follow 3 steps to solve this problem. One is to reverse the entire array. So if I reverse the entire array, it comes to 7, 6, 5 and goes all the way up to 1. Okay, so this is the entire array which has been reversed. Okay, so I'll just write it off. Okay, so now we just need to reverse the array from kth elements. Okay, so k is 3, so we need to start from the first index and go all the way up to k elements. Okay, so that is 0, 1 and 2. Okay, so k will be the length of the array, that array size that we need to reverse. Okay, so we reverse only the first 3 elements, so that is 5, 6, 7, and then leave the remaining elements as the same. Okay, so this is the second step. We reverse only up to the first k elements, and the last step is to reverse the, as you guess, the last k elements. Okay, sorry, the from the k index up to the end of the array. Okay, so k is at 3, so we need to start from here and reverse the array, reverse the rest of the elements from here. Okay, so we get 5, 6, 7, 1, 2, 3 and 4, which is the resultant array we need to return. Okay, so we are not going to use the regular JavaScript reverse function, but we are just going to create a helper function, let's say reverse. Okay, so in this function we need to specify the start index and then the end index. Okay, and the entire array itself. Okay, so what will be the start index for the first step that we are doing to reverse the first k elements? So we create a function with passing in the array, and then from the first index and up to the the 0th index up to the second index. Okay, since the k is 3. Okay, and then we what we do is we just swap elements. Okay, so the 5 we put at the first index and 7 at the last index. Okay, so we just keep swapping the first and the last indices. Okay, and the same we do for the second step as well. Okay, so we have 1 over here. Okay, so 1 we swap it to the 4, and then from 2 to 3. Okay, so this gets reversed. Okay, so by this we are getting very efficient performance by using this technique. Okay, and let us calculate the time and space complexity. So the time complexity, as you guess, it is O of n, because we are just calling the reverse function 3 times, and this is only on the subset of the arrays. Okay, so that is from this and this. Okay, so that is again 3 times, so again that constitutes to just O of n, because we are not doing for the entire array, right? So, and what is the space complexity? It is just O of 1, because we are not creating any additional variables within our code. Okay, so this is the most efficient way of solving this problem. So let us understand how we can write this in code. So to solve this problem, we'll be given the numbers array and the number of times to rotate, that is k. Okay, so this k can also be out of range, so we need to counter this by taking the remainder of the length of the array we have within our nums. Okay, so for that we can just say k is equal to k percentage nums dot length. Okay, so since you see that within the constraint they have said that k can go all the way up to 10 to the power 5. Okay, so we have just solved the problem. So now k will always be in range, okay, between the start and end of the array. Okay, so between the length of the array. All right, so once that's done, we can now create a helper function to help us reverse the given array. So that is from 0 to k, and then from k to the last element of the array. Okay, so let us create a function called reverse, and we just need to pass in 3 things. First is the array itself to reverse, and then the start and the end. All right, so in our case it is nums. Okay, so within this function we just need to run a loop. Okay, so we do not know how much will be the elements within the array, so we run a while loop and then we swap elements. Okay, so this is how we can reverse the elements within an array. So while, let's say, start is less than end. All right, so within this loop what we are just now going to do is we store the value within a temporary variable. Okay, so even in your college days you would have starting you would have taught how you can swap 2 elements. Okay, so that is the same approach we are just using over here. So let's create a temp and store the first index within the array, so nums at start. All right, and then we swap that, then we set the nums at start to the nums at end. All right, so then we set the nums at end back to the temp. Okay, so this is how we swap variables, okay, so sorry, swap elements within an array, and all we just need to now do is call the reverse function that we created and then pass in the array and then the starting index and the end index. Okay, so that is 0. So for the first step that we are going to calculate, that is from 0 to the kth element. Okay, so that is so sorry, we just need to rotate the entire array, right? So we pass that array dot length, and since arrays are 0 based, so we need to subtract 1, and yeah, so finally within this end, within this while loop, so we just increment start and decrement end. All right, so once that's done, we can do the same for the other things. So that is from 0 to k and from k till the end of the array. Okay, so again we can just duplicate this and pass in the array again same, but this time it's just going to k. Okay, and remember arrays are 0 base, so k minus 1, and we now go from k to till the end of the array. Okay, so once this is done, sorry, this should be nums. Okay, so I just get confused between array and nums. Okay, so whatever is passed it. So once I do that and try to run the code, okay, so yeah, and that passes. So if I try to submit this, let's see our performance, and yeah, okay, so it beats around 96% of our competitors. So this is the solution for the problem, that is rotate array. So let us now move ahead to the next problem. So this is a problem where we need to check if there is any duplicates within a given set of numbers. Okay, so you see that this is a fairly simple problem. By the way, you can quickly like find out a way how you can solve this problem. So there are many ways of solving this. I'll just come to that. So you see that this is a given array where we see that 1 is being repeated 2 times. So this is contains duplicates within this array. So we need to return false. Okay, a true or false value in the end. So if it doesn't contain any duplicates, then we return true. All right, so there are two approaches to solve this problem. The first one is by sorting the array itself. Okay, so if I sort the array, it would be 1 1 2 and 3. Okay, so what is the time complexity that is involving in the sort operation? That is n log n. Okay, so this is the time complexity, and the space complexity is O of 1. Okay, and this is the time complexity. So this is the approach which takes a little bit of time for the calculation, but it doesn't consume any extra memory within your place. Okay, so this is approach 1 by sorting the array. So we check that if the first element within the array is equal to the immediate next element. Okay, so if those two are equal, then obviously there is a duplicate, then we return false. Okay, else we return true. So as simple as that. So this is approach 1, that is by sorting the array. Okay, and the second approach is by creating a set. Okay, so set is a type of is a data structure in JavaScript that holds unique values. Okay, so basically what we do is we create a set. So let's assume this to be a set. Okay, and we just need to keep on adding values. Okay, so we add on the first value and the second value and the third, and we just need to check for the fourth value for every element within the set if it is already existing. Okay, so we have a property called has, which takes in a O of 1 operation. So that is fast lookup. Okay, so it doesn't have to loop through the entire array. So it just checks whether the element is already there within the array. So then it returns true or false value. So if it is already there, then we obviously return false since there is a duplicate. If it doesn't contain, then we need to loop across till the end of the array, and after that, if we do not find any element within the set, then we return true. Okay, since there are no duplicates. So the time complexity in this approach is O of n. Okay, so since we are looping across each element within the array, and the space complexity is also O of n. Okay, worst case that we have the entire set to be each an element within the array. Okay, so we just need to compromise on any one thing, either the time, okay, or the space. Okay, so if we want to have a least amount of space complexity, then we can go with the first approach. If you want to get the best time complexity, we can go with the second approach, that is just O of n. Okay, so which is better than O of n log n, and also the same. Okay, so we just need to compromise on any one factor, that is the time or the space. So let us know how understand how can we write this in code. So let us start with the first approach by sorting the numbers array. So nums dot sort, which takes in the two comparison elements, and we just need to sort them by the ascending order. Okay, so a minus b. Okay, so now our nums are sort. So now we just need to run a loop from the start of the array. So let's say let I equals 0, I is less than nums dot length, incrementing I. So now we just check if the ith iteration, the value of that is equal to or not equal to the immediate next value of that. Okay, so let's check if nums at I is equal to nums of I plus 1. Okay, then we return true. Okay, which means that there is a duplicate. Okay, so if we go until the end of the array, if we do not match this condition, that is the immediate next value, if it is equal, then we finally return false. Alright, so if I save this and try to run this code, so it passes. So if I try to submit this and see our performance, and by time complexity it beats just 12%, which is terrible. Okay, so not good for time complexity, but when it comes to space complexity, it beats almost everyone. Okay, so 92%. So now let's look at the second approach, where the space complexity is bad but the time complexity is the best. Okay, so let's get rid of this, and so let's create a set. I'm going to call this scene. Okay, so which stores all the scene variables. Okay, so which are the variables which we already checked. So new set. So now we just need to run a loop. So I'm going to use the for of loop by saying let nums of nums. Okay, so this is basically used to loop across any object type. Okay, so let's check if the set, that is scene dot has. Okay, so this is applicable for set data structure, and we pass in the number itself. Okay, so at the current iteration, then we return true. Alright, okay, so if that number doesn't exist within our scene set, then we add that to that. Okay, so scene dot add the number itself. Okay, so scene, and then finally we return false if we do not find any duplicates. Okay, so basically if we do not find anything within our set. Okay, so which means that there is no duplicates, and then we are just returning false. So if I run this, so that passes as well. So let's check the time complexity this time. So the time complexity is almost 100%. Okay, so it's 97, which is beating among all the other competitors, but also the space complexity is a little less, okay, than the previous approach. Okay, so I guess we need to go with this approach, since we are having a good time and space complexity. Alright, so this is all for this problem. Let's now move ahead. So this is a problem called +1, where we need to add a number to the last element within the array. Okay, and suppose for example this is an array where with numbers 1 2 3. So if I add 1, like let's say this is a number 123. So if I add a number, it becomes 124. Okay, so we need to return that in the form of an array. So 1 2 and 4. Okay, with a digit and separated with a comma. Okay, where each digit represents each element within the array. Okay, so however there's a challenge over here. So what if the last element is 9? There is a carry. Okay, so we need to also counter that case. So this is an example which contains a carry, where if I add a number at the last element of the array, so it becomes 10. So we just need to loop across from each and every element within the array from backwards. Okay, so we just like set a pointer, let's say I, and we just add a number to that. So 9 plus 1 becomes 10, and we just need to check now if that is lesser than 10 or not. So if it is lesser than 10, then we just add that one digit and return the entire numbers array itself. Okay, so if it is not less than 10, which means that there is a carry. Okay, so then we just need to go to the next iteration and try to add 1 over there. Okay, so let me explain how does this work. So at the ith iteration, which is at the last element within the array, and if I just add a number there, it becomes 10. I need to check if that is lesser than 10. So 10 is not lesser than 10. Okay, we are not using lesser than or equal to, just lesser than 10. So if that is true, then we add the element, or we make that 0 and add the carry. So we go to the next element. So we make this 0 and go to the next element, and there we just need to add 1 and check if that is less than 10. Okay, so again 9 plus 1 is 10, so that is less than 10. Again the condition fails, so we just make that 0 and increment I. Okay, and now again we do the same. So this is also not less than 10, so we increment I. Okay, so now I is no more. Okay, so this, we have reached the end of the array, and we also make this 0, and we get finally 0 0 0. Okay, so until we reach at the end of the array, if we do not find, or if we do not return the digits array, we just need to add 1 to the first starting element within the array. Okay, otherwise it becomes full 0. So this is the final result. Okay, so again I repeat, if we do not find any number less than 10, that means that we have loop across all the array, but we did not find any number less than 10. So we just need to add 1 at the start of the array. Okay, so it becomes 1000 like this, and 999 plus 1 is 1000. Okay, so let us now understand how to solve this in code. So let us loop across the digits array from the reverse order. So let's run a for and set the I value to the last element of the array. So let I equals digit dot length, setting I if that is greater than or equal to 0, and decrementing I. So we are going from the reverse order, right? So we just increment the last number within our digits array by 1. So we can just say digits at the ith iteration plus plus. So that will increment that. So now we need to put a check if that is equal to or less than 10. So let's put if digits is at ith iteration is less than 10, then we return the digits itself. Okay, which means that that number is not 9. Okay, so it is less than 9. So if we add that, we do not have a carry, so we return the digits itself just by adding this. Okay, so if there is a carry, then we make the digits at the current iteration to be 0. Okay, and then we loop across all the elements and then check for the same. Okay, so after we complete the loop, which means that all the numbers were 9, so we just need to add 1 at the start of the array. Okay, so let's set digits dot unshift. Okay, and set that to 1. Okay, so this will add an element to the start of the array. So that's what this method does, if you know about arrays in JavaScript. So unshift, and then we just return the digits. So now if I run this, sorry, this should be digits dot length minus 1, and with that if I run this, so our test passes. So if I now submit this, so we are getting 100% better in time complexity, but not that much in space. Okay, so this is the solution for this problem, that is +1. So now let's move ahead. So this is a problem where we need to calculate the maximum subarray. So what do we mean by subarray? Come to 6. Okay, so this is the maximum subarray. So we need to find this array for any given set of numbers. Okay, any element like from here to here. So if I consider this to be an array, so that's a subarray. Okay, so we just need to calculate what will be the maximum. So if I calculate that from the start till the end of the array, so that number should be maximum than the other numbers. Okay, so we need to calculate that. So for example, you see that this is the maximum subarray. Okay, so if I add in 4 minus 1 plus 2 and add in 1, so it becomes 6. Okay, so if I compare that with others as well, so that doesn't. So this problem can be solved by using the cadence algorithm. Okay, so this algorithm, so cadence algorithm, so what it says that the idea is to iterate through each and every element within the array and maintain a running sum. Okay, so we can call that running sum or current sum, and first initialize that to 0. Okay, so we just start from the first element of the array and just keep adding on to that, and the moment we see current sum is less than 0, we again reset that back to 0. So there is no point in starting from a negative. Obviously that will not be the subarray, so we just always need to start with a positive number. Okay, so that is why we need to if that is less than 0, so we do not want to the subarray to start from minus, so we always reset that back to 0. So during this process we keep track of the highest sum that has been encountered. Okay, so we can create another variable called max sum. Okay, and set this to 0. So for every subarray that we calculate, we just need to add them and just check with the maximum sum. If that is greater than or equal to the previous value, then we update that, otherwise it is still the same value. Okay, so let us understand just by an example. So you see that it starts with -2, so I keep the current sum to 0 itself, and then this is 1, so now I update the current sum to 1. Okay, and then go over here, again this becomes -3. Okay, so -3 and 1, it becomes 0, so I just need to reset this back to 0, because 1 minus 3 is -2, right? So we do not want negative running sum, so we reset that back to 0, and then we go to the next element, that is 4, and then update the current sum to 4. Okay, so we are again starting from here as the initial point of the subarray, and then go to the next element, that is -1. Okay, so we again update the current sum to 4 minus 1, that is 3, which is a positive number, so that is why we are keeping it as 3 itself. And then we now go to the third one and then add 3 and 2, so that becomes 5. So this is the current sum. Okay, and then we keep on going unless we get the current sum to be negative. Okay, and simultaneously we also need to update the max sum as well. Okay, so we need to compare the current sum and the max sum. Okay, so obviously current sum is greater than max sum, so we update the max sum to 5. Okay, so I had to do this before, but okay, anyways, so now we move on to the next element, so that is 1. So we just add the last element to the current sum, that is 6, and we check with the max sum. So obviously current sum is greater, so we update the max sum to 6, and then we increment this subarray, okay, by adding -5. So current sum becomes 6 minus 5, that is 1. Okay, so max sum is still greater than the current sum, so we remain that to be 6, and then go to the last element, that is 4. Okay, and now we check 4 plus 1, that is 5. Okay, so the max sum is still greater than the current sum, so we remain that to be as 6 itself. Okay, until we reach at the end of the array, so we return finally the max sum, that is 6. Okay, so in this problem statement we just need to return what is the maximum value and not the subarray itself. Okay, so if we notice this is the subarray, okay, which will return as the maximum sum. Okay, so we don't have to return the array but just the maximum sum. Okay, so let us now understand how can we solve this by code. So let's initialize the max sum and the current sum. So let's say max sum and set that to the first element of the array. Okay, so that is nums at 0 and the current sum, and I'm going to set this to 0. Now let's loop across all the elements within the array. So let I equal 0, I less than nums dot length and I plus plus. So we need to now add the number to the current sum. Okay, so this is going to be the running total unless it doesn't go back to negative. So let's put plus equals to the num set I, and now we just need to check with the max sum. Okay, and we just need to update this. If it is greater than or equal to the max sum, then we update that to the current sum, else we just leave that to the max sum itself. Okay, so max sum is equal to, we use the math JavaScript library dot max, which will compare two elements and return the maximum value. So let's pass in the max sum first, which is over here, and then we pass in the current sum. All right, so there's one more step to be done, that is to check if the current sum is gone back to negative. Okay, so if it is gone to negative, then we reset back to 0. Okay, so if current sum is less than 0, then we put that to 0. All right, so finally we return maximum. Okay, so now if I run the code, okay, so this should be equals. Okay, so my bad, just a typo there, and that passes. So if I submit this, okay, so this is for the time and space complexity. It's not the best, but this is the valid solution. Okay, so now let's move ahead. So this is a problem called missing number, where we need to find the missing number within a given set of numbers. Okay, so you see that we have an array of numbers, so we need to calculate what is the number that is missing. Okay, so we can clearly see that the number 2 is missing. Okay, so we need to just return the answer as 2. Okay, so there could also be a situation where we do not have any missing element. Okay, assume that this is an array 1 comma 2 comma 3, and there is no missing element. Sorry, this should start with 0. Okay, so we need to return the last element, that is 4. Okay, so we just need to return 4 over here. So 0, 1, 2, 3, and the missing element is 4. So that's what we need to return. So what is the brute force way of solving this problem? So we loop across every element within the array. So we check if that particular element is there within the array or not. Okay, so we calculate that by the index. Okay, so here the index is at 0, so we check 0 is there within the array or not. Okay, so the 0 is there, so we go to the next one, and then we check 1 is there or not. So 1 is also there, so we just go to the next iteration, so that is 2. You see that 2 is not there within the array, right? So 2 is a missing number, so that's what we need to return over here. So what is the time complexity with this approach? It is O of n, so worst case, and the space complexity is O of 1. Okay, so there's nothing wrong with this approach. This is also a good approach, but how can we make this better? So there is a small trick which you can apply in order to calculate the missing number. Okay, so if you use this trick, you can impress your potential employer who is giving you this problem to solve. Okay, so what is the trick? So what we just do is we calculate the entire sum within the array. Okay, so what is the sum of this? So the sum is 4, and we need to calculate the sum that is for the length of the array. So what is the length? So the length is 3, right? So what is the sum? So that is 1 plus 2 plus 3, that is 6. Okay, so this is the expected sum, but the resultant sum is 4. So we just need to do 6 minus 4 to is the answer. Okay, so how do we do this? We have a formula, that is n into n plus 1 divided by 2. Alright, so n is the length of the array. So what is the length of the array? That is 3. So 3 into 3 plus 1 divided by 2. So this would come to 3 into 4 is 12. So 12 by 2 is 6. Okay, so 6 minus the sum of the given array. So 3 plus 1, that is 4. So 2 is the missing number. Okay, so it's a good trick, but this is also solve this problem in an efficient way. So again, the time complexity is still O of n, and the space also we are not creating any additional data structure, that is O of 1. So to do this calculation, it doesn't require any kind of time complexity. All it just need to do is add up numbers. Okay, so you can use any one of the approaches. By using this formula, you can solve this in a more professional way. Okay, so let us see how can we solve this by code. So let's first calculate the length of the nums array. So let's say n equals nums.length. Okay, so now let's put the formula and calculate the expected sum. Okay, so const expected sum, and set that equal to n times n plus 1. okay, and finally divide that whole by 2 like this. And now let us calculate the actual sum. Okay, so I'm going to use a higher order array method called reduce. So I'm going to operate that on nums dot reduce, and this will take in two parameters, that is accumulator and the number itself, and we just need to add those two. Okay, and the initial value of the accumulator is going to be 0. Okay, so all we now need to do is return expected sum minus the actual sum. Alright, so if I now run this, so that passes, and let's submit. Okay, so time complexity 100% and space almost 100, okay, 84%. So this is a solution for the problem missing number. So now let's move ahead. So this is a problem where we need to calculate the maximum product of three numbers. Okay, so you should also keep in mind that minus into minus becomes plus, right? So that also we need to counter that. So this is a quite challenging and an interesting problem to solve. So okay, so this is a given set of numbers where we need to calculate three numbers within this array that would give us the maximum result, that maximum number. Okay, if you calculate minus 10 into minus 20, so that would become 300, so which is a positive number. So minus into minus is plus, and we need to choose any one number where if we multiply it would give us the maximum number. So far we have done for two values, so we need to do for three. So that is 5. 300 into 5, that would give us 1500. Okay, so this is the maximum product for three numbers within this given set of numbers. Okay, so how do we solve this? So what logic do we apply? So one thing we can do over here is we can sort the given array. Okay, so by sorting, this would become minus 20, minus 10, 1, 3 and 5. Okay, so this is the sorted array, and here we just need two solutions. Okay, so the first one is the first two elements, so that is the negative ones, and multiply that to the positive one. So we just did that, right? So negative into negative becomes positive, and we multiplied that to the maximum value, right? So if you multiply to the maximum value, it will give us the maximum result. So that is one approach. So product of two small numbers multiplied by the largest number. Okay, and the second approach is to calculate the product of three largest numbers. Okay, so three largest numbers is we just need to take the last three elements within the array. So this is the second approach. So product of three largest numbers. Okay, so that is 1, 3 and 5. Whereas for this first approach is minus 20, minus 10 and 5. Okay, so we just need to compare which is the largest, and we just need to return those particular numbers. Okay, so the product of 1, 3 and 5 is 15. Okay, and we need to compare to the product of the first approach, that is we already calculated that is 1500. Okay, so which is greater? So the first approach is greater, so we need to return these three numbers, minus 20, minus 10 and 5. So these are the three numbers that make up to the maximum product. Okay, so what is the time complexity to solve this? So the sort operation itself takes a time complexity of O of n log n. Okay, and then we are just doing the multiplication. Okay, and what is the space complexity? That is just O of the worst case could be the entire array itself, so that is also O of n. Sorry, I just checked, we just need to return the maximum number instead of this array of numbers. Okay, so the space complexity would be O of 1. So if they ask you to return the set of numbers, then it becomes O of n. That's the worst case. Okay, so in the problem statements we just need to return the maximum product. So that's the problem. Let's see how can we solve this by code. So let's start by sorting the nums array. So I'm going to use a sort operation on arrays basically. So where it takes in two parameters a and b and just set that to a minus b for ascending order. Okay. So now our numbers are sorted in ascending order. So now let's keep a track of our length of our nums array. So const n equals nums.length. Okay, so now we just want to calculate the product of three largest numbers. Okay, so let's store that within let's say max1 and set that to nums at n minus 1. Okay, so that is the last element within the nums array, so n minus 1, and multiply that to n minus 2, nums of n minus 2 and n minus 3. All right, okay, sorry, this should be n minus 3. And now we calculate the second product, so that is the product of two smallest numbers and the largest number. Okay, so the reason why we are doing this, as I told you, that two negative numbers can make a positive number, right? So that could also be the case. So let's say nums at 0 and multiply that with nums at 1. Okay, so the first two elements within our nums array and multiply that with the last element. All right, and now return math.max. So this should be max2, and return math.max, and then pass in the two variables. Okay, so let's run. So that passes, and if I try to submit, so not the best in time complexity. As I told, the sort operation takes in a time complexity of O of n log n. Okay, and takes a space complexity of about 60%. Not the best solution. So let me just show you the best solution, which I haven't explained yet. So I'll just go ahead and paste that particular code. So basically we are not sorting the array, so we are just keeping track of certain variables, like three max variables, which is set to the smallest number possible, that is minus infinity, and min1 and min2 to be the largest positive number, that is plus infinity. So by mistake I just copied this. Okay, so what we just do is we loop across all the nums array in each, okay, individually. So first we check if the num is greater than the max one, okay, which is minus infinity. So then we update the three variables that we have. So we check if the number is greater than max one, okay, which is minus infinity. So we update the respective variables. Okay, so the max one is going to be the current number of this iteration, and max 2 is now going to be max 1, and max 3 is going to be max 2. Okay, this is a shorter way of updating variables that we have using a let keyword. Okay, so then we check if the number is greater than max 2. Okay, so again now the variables are updated, right? So that will keep a track of that. So we update accordingly. So max 2 becomes the num and max 3 becomes the max 2 this time. Okay, so again we check that if it is greater than max 3, and then the max 3 is equal to the number itself. Okay, so what we are just doing is updating three largest numbers, and simultaneously we update the two smallest numbers as well. Okay, since minus into minus makes plus, so we update only two smallest variables and not three. So now we check within the same for loop if the number is lesser than this min 1, which is set to positive infinity. So we update the min 1 to be the number and min 2 to be min 1. Okay, and do the same if the number is less than min 2, and then make min 2 the current number itself. Okay, so by this we are having two groups of numbers. One is for max 1, max 2, max 3, and then min 1 and min 2. Okay, so all we now need to do is make a comparison between the product of three maximum numbers, so max 1, max 2, max 3, calculating the product of it, and then the product of two smallest numbers, that is min 1 and min 2, and then multiply that to the max 1. Okay, so this is the most efficient way of solving this problem, I guess, since we are not dealing with any sort operations, and we are just creating some extra variables, so that would compromise on the space complexity a bit. So let's run this code and check. So that passes as well. So if I try to submit, and this time let's see what is the space and time complexity. So you see that our time complexity is now been improved, so about 85%, and but it has compromised on the space complexity since we have created too many variables over here. Okay, so we just want to compromise on any one thing, either the time or the space, okay, based on what exactly is your concern. Okay, so this is the solution for the problem, maximum product of 3 numbers. So let's now move ahead. So in this problem, we need to calculate the majority element. Okay, so what is the majority element which appears more than n by 2 times within the given number, where n stands for the length of the array. Okay, and we can assume that the majority element always exists, okay, according to the problem statement. So this is a given set of numbers where you see that 2 is the majority element, where it is satisfying this condition, that is appearing more than n by 2 times. So 2 is being appeared 4 times within this array, and that is greater than n by 2 times. So what is the length of this array? So that is 7. 7 by 2 is like 3.5. So the appearance of number 2 is greater than 3.5, or you can assume 4 itself. So we can return 2 as the majority element. Okay, so how do we solve this? So the brute force way of solving this is by comparing each element, the frequency of every element within the array. Okay, so basically we create nested for loops, which we should avoid creating. So this is the brute force way. So where I compare I set I over here, and we just need to compare the frequency of this particular number, which is at ith iteration. So we see that we compare 2 elements. So if I equals to j, then we have a count variable, and initially we set that to 0. So if they both are equal, we increase the count, which means that that is the frequency of that. So we increase that to 1, and then increment that and check that if these two are equal. If they are not, we keep incrementing until they are equal. Okay, once they are equal, we upgrade the count variable. Okay, and then keep doing this. Okay, and then once we complete the first for loop, then we increment I and check the frequency of this second one. Okay, so we keep on doing that, and this takes a time complexity of O of n square, and whichever the number which is having the maximum count, we just need to return that particular number. Okay, so this is the brute force way. And what is the time complexity? It is O of n square, the nested for loops, as you know. And what is the space complexity? We are just returning one number, right? So we are creating one variable, so we can assume that to be O of 1. So this is the brute force way, which is not usually the most preferred way. So what is the best way of solving this problem? So we can use the Boyer-Moore's voting algorithm to solve this particular problem. So in this method, we create a voting system. Okay, so let's say these are all the candidates within the array, and we are like voting for which particular candidate is the majority element. Okay, so let's say I vote for number 2. So number 2 has got 4 votes. So that is the majority element, right? So we can create something like that. So we can keep count of 2 variables. One is the candidate and one is the count for the number of votes for that candidate. So candidate and votes. So we loop across every single element within the array, and for every element that will be the candidate. Okay, so 2 is the candidate, so we can assign that to 2 for the first iteration, and then we increment I. Okay, and also we can just set this to count instead of votes. Okay, so the first count is 1 at the first iteration, and then we increment I. So I is at the second level. So again, the same candidate, we need to check if the candidate is the same or different. Okay, so we need to increment the count. So now count is 2. Okay, so increment I again. So now this is a different candidate. Okay, so we need to decrement the count once we find another candidate. Okay, so 2 minus 1 becomes 1. Okay, and candidate still remains 2. Okay, unless it goes to negative. Okay, so now we increment I. Okay, now I is a same one, but the candidate is 2. Okay, so still we need to decrement. So minus 1 becomes 0. Okay, so now again we increment I. Okay, now you see that count is going to negative. Okay, so that means that 2 is no longer a valid candidate. So we need to update 2 to 1. Okay, and increment the count. Okay, so again we increment I. So now the candidate has changed, so we got a new candidate. So we need to decrement the count. So 1 minus 1 becomes 0. okay, and still the candidate is 1 as long as it doesn't go to negative. Okay, so now we increment I. Okay, so again it's going to negative, right? So we need to change the candidate to 2 and increment the count. Okay, so we have reached till the end of the array. So you see that the candidate is 2 and the count is 1. Okay, so this is the candidate which we need to return at the end. So 2. So 2 is the majority element. So for this particular given set of numbers. Okay, so what is the time complexity involved with this approach, that is Boyer-Moore's voting algorithm? So we are just looping across once throughout the array, so the time complexity is O of n. So the number of elements in the array is the time complexity, because we are looping across every single element within the array, and the space complexity is just O of 1, since we are just creating two variables and not based on the number of values within the array. So this is the solution for this problem. So of course this is better than the brute force way, where we have had the time complexity of n square. So this is the time and space complexity. Let us see how can we solve this by code. So let's initialize the two variables, one for the candidate and set that initially to null, and another one for the count. Okay, so the count initially is going to be 0. Okay, so let's now loop across the nums array. So I'm going to use the let num of nums, so the for of loop. All right, so now we just need to check if the count is 0. Okay, so if it is 0, then we make the num as the candidate. Okay, so let's check if count is equal to 0, then we make the candidate to be the num. Okay, so after that we increment the count based on the num being equal to the candidate. So let's increment count, and we just need to make a check here. So let's check if num is equal to the candidate. So basically we are checking if the number is still a candidate, then we add 1. Okay, else we subtract 1, and finally return the candidate. Okay, so let's run. So that passes, and let's submit. So yeah, this is the solution for the LeetCode problem, majority element. So now let's move ahead. So in this problem, we need to find all the numbers that are being disappeared within a given set of numbers. Okay, so you see that this is an array which also contains some duplicates. Okay, so which ranges from 1 to n. Okay, so it says that we need to return an array of integers from 1 to n. Okay, so it starts from 1 and goes all the way up to n, which is the length of the array, and that do not appear in the nums array. Okay, so clearly we can see that the numbers 5 and 6 are not present within this array. Okay, where it starts from 1 and goes all the way up to the length of the array, that is 8. Okay, so 1 is there, 2 is there, 3 is there, 4 is there, 5 and 6 are not there. Rest of the other elements are already present within this array, even though they are duplicates. You see that 2 has been appeared 2 times and also 3. Okay, so there can be duplicates, so we just need to find what are all the elements which are not present in this array. So this is similar to the missing number LeetCode problem, but there we just need to return what is that one number that is missing, but here we need to return an array of numbers that are missing. Okay, so how do we solve this? So the brute force way of solving this is by creating a set of the length n, okay, where each and every element would be the increment of the previous number. Okay, so it would be like 1 2 3 and goes all the way up to the length of the array, so that is 8. Okay, so this is a set, okay, not an array, and we just have a method called delete, which is a fast deletion. We just need to specify that particular value and that will delete the element. Okay, so what we just do is we loop across every element within this array and we check within the set, okay, and just delete that particular value. So if it is there, it will delete, otherwise it will do nothing. Okay, so you see that 4, if I have 4 over here, it will delete within the set, and it will also delete 3, and whatever the elements which are present in the given array, so that will delete within the set, and what we'll finally have is an array of 2 values, that is 5 and 6, since they are not even there within this array to delete, right? So these are the 2 elements. So what is the time and space complexity? That is O of n, same for time and space, since we are creating an additional data structure for the set. Okay, so this will also take a space complexity of O of n. Okay, so how do we solve this? How do we make this better? So there is a technique which we can use in order to find those missing elements. Okay, so we cannot apply that formula that I told in the missing video LeetCode problem, so that is n into n minus 1 by 2. So that will just return one value, and we just need to calculate the array of missing elements, right? So what we can just do is, we see the first element. So what is the first element? That is 4, and we just need to treat this as an index of this array. So what is the index 4 pertaining to? That is 7, right? So basically arrays are 0 based, so we need to minus 1, by the way. So we just need to make this negative. Okay, so this becomes minus 7. Okay, so we are not creating an additional data structure, we are just modifying the given array itself. Okay, so this will help us in space complexity. So we just put this minus 7. Okay, and we just need to treat each and every element within this array as indices. Okay, and just mark them as negative. Okay, so if they are already negative, we do not want to mark them as positive. Okay, so they will be negative itself. So what is the second index or the first index? So that is 3. So what is the index of 3? That is 2. Okay, so we just need to make this as negative. Okay, so now what is the value at index 2? Okay, so we just treat this still as positive. Okay, indexes are like always positive, so we just need to negate this, so it becomes minus 3. And the next one is 7, right? So this is the 7th element, so that is 3, and make this as negative. And next 8, negative. Okay, so the 8th index. And then for 2, so since this is already minus 3, so we do not want to make this as plus 3. Okay, so this still remains minus 3. Okay, and then we go to 1, so that is 4. So this is the final stage where we have looped across every element within the array, and we just need to check those numbers that are still positive. Okay, so what are those two numbers? Okay, so that is 8 and 2. Okay, so we just need to return the indices of those two numbers. Very simple. So what is the index of 8? So that is 0, 1, 2, 3, 4. So we just need to add 1 since we are starting at 1. Okay, since we had already subtracted for 1 for the index, right? So this becomes 5. Okay, and what is the index at 2? That is 6. So these are the two missing numbers. If you can verify, you can just check it. So 5 and 6 are not there within this given set of numbers. Okay, so we are not creating any extra data structure in order to keep track of missing numbers. So the space complexity is O of 1, while the time complexity is still O of n. Okay, so this is the solution for this problem, to find all numbers displayed in an array. So let us see how can we solve this by code. So let's loop across all the numbers. So let's say for let num of nums. So as I told, we need to treat this number as an index. So we can just create an index and set that equal to math.absolute. So this will always give us a positive number. So the index, even though if it is negative, we treat that to be positive to get the index basically. So we pass in the num, and since arrays are 0 based, we need to subtract 1. So now let's check if the nums at the particular index is greater than 0. So which means that if it is positive, then we make that negative. Okay, so if it is already negative, we don't do anything. So this doesn't fall inside this block. So let's set nums at index and set that to minus nums of index. So now we just need to filter out those values that have a positive number. Okay, and just return the indices of those two. Okay, so let's create a result variable here and set this to an empty array. So now we check those values that are positive and just push those indices to the result. Okay, so let's put a for let I equal 0, I less than nums dot length, and increment I. And inside this we just want to check if the number is positive. So if nums at the particular iteration, if that is greater than 0, which means that it's positive, then we want to push that to the results array. So results dot push the particular index. Okay, so since we have subtracted 1, we also need to add in 1. Okay, over here. Okay, so then we just need to finally return the result. All right, so this should be 0, and let's run. Sorry, result dot push. So that passes, and now if we try to submit, so yeah, we are getting good time and space complexities. So this is a solution for the problem find disappeared numbers. So now let's move ahead. So this is a problem where we need to return an intersection of two arrays. Okay, so what is an intersection? Which are those numbers that are common between given two set of numbers? Okay, so you see that within this given two arrays, the number 4 and 9 are both common between the numbers 1 array and numbers 2 array. Okay, and also 9 has been repeated even in array 1, so we just need to return unique elements. Okay, so that's what the problem statement says: return an array of intersecting elements and each result element must be unique with any order. Okay, so order can be anything, and we just need to return the intersecting. You see that I have explained with the help of this diagram. So this is a nums array 1, okay, and this is elements in nums array 2. So 9 and 4 are appearing in both the arrays, right? So even though if there is a 9 here, okay, so I don't add that within the intersecting, so I just want all the unique elements in here. Okay, so we just don't add in duplicate ones. So these are the two numbers which we need to return, 9 and 4. All right, so what is the brute force way of solving this? So we create an empty set. Okay, so this is not an array, so this is a set. Okay, and we create an empty set, and we compare every element from nums 1 to nums 2. Okay, so we create nested for loops. Okay, so this is the brute force approach, not the most optimal way. So we compare, we set I here and set j here, and see if 4 and 9 are equal. So if they are not equal, we just move to the next iteration. So we increment j. So now they are equal, so we just add them to the array. Okay, and now we increment j. Okay, so we just keep on doing this, and even though we find both the elements I and j are equal, since 4 is already there, so we do not want to add that. Okay, so since this is a set, this will be taken care by itself by storing unique elements inside that. So set basically stores unique elements, right? This is all we need to do, and we now increment I. Now we see I and j are both equal, so we add that to the set. Okay, and we just keep doing the same process. Okay, so we find finally that 4 and 9 are the both unique elements that are present in both nums 1 and nums 2. Okay, so this is which we need to return. So the problem in this is we are creating nested for loops, and also we are creating another data structure, which the worst case could be O of n, right? So what is the most optimal way of solving this? So what we can do is we can create a set for the first array, so nums 1. So basically it holds all unique values. So even though there is a duplicate, it will store all unique ones, so 4, 9 and 5. And we compare every element from nums 1 to nums 2. Okay, so make a distinction here, we are not creating a nested for loops, we are just checking if that is already there within nums 2. Okay, and we create another set over here for the result, which we need to return at the end of the program. So I can just create a empty set. So this is the result set. Okay, so this is the set for the nums 1. Okay, so which is also a set. Okay, so I can just also call this set. So this is the result set, and we just need to compare from nums 2 if it is already present in nums 1. Okay, so since the lookup within sets is taking an operation of O of 1, so we just don't have to loop every single element and check if that is existing in the array. So that is one of the main benefits of using set, guys. So that's why we are using set here. And now we check 9 if it is there within the array 1. Okay, so yes, that is there, so we add 9, and then check 4 if it is there. Even 4 is there, and again 9 is still there. Since this is a set which will not store duplicate values, so it still remains in the same state. And then we compare 8 if it is there, so 8 is not there. So again 4 is already there, so we do not store duplicate values. So this is the final result which we need to return. And of course I told you, right, this can be in any order. You can even do 4 9 or 9 4. So this is the ultimate result which you need to return. Okay, and we need to return in the form of an array, but not in a set. So we need to convert this set back to an array. Okay, so we can just spread across whatever is there within the given set. This will convert back to an array. Okay, so what is the time complexity over here? That is O of n, since we are just making one comparison from nums 2 to nums 1, and we are not creating nested for loops. So that's the main point over here. Okay, so that's why, so it usually becomes O of n plus O of n. So but that still constitutes to O of n, right? So what is the space complexity? So that is O of n. So worst case, we can have all the elements which are there in nums1 as well as nums2. Okay, so all the elements would be intersecting. So that is the worst case. So that is O of n, right? So this is the solution for this problem, intersection of two arrays. Let us see how can we solve this by code. So let us create a set for nums1. So I'm going to call the set1 and instantiate a new set, okay, and pass in nums1. So this is going to return us an array with all the unique values, and let us now loop across all the values from nums2. So I'm going to use the for of loop. So for let num of nums2, okay. So inside this we are going to check if each element within nums2 is already present in set1, then we store that within the resultant array. Okay, so let us create that resultant array, or let's call this result, and set this to an empty array. So let's check if set1 dot has. So since this is a set, it has a method called has, where we check if that element is present within the set. So that will return us true or false value. So let's pass in the num. So if that is true, then we add that to the array. Okay, so result dot push and pass in the num, and finally we return the result. Okay, so let's run this. Sorry, this should be set1, and let's, so we are getting a wrong answer. So the output should just be 2, okay, and we are adding 2 and 2. Okay, so it says that each element within the result must be unique. Okay, so sorry about that. I just thought it can also include duplicates, so I just also told that. So sorry for that mistake. Let's convert this result also to a new set which will hold unique values, and let this be empty. And once we find a match within our set1, we can do result dot add and pass in the num. Okay, and this will be in the form of set, right? So we just need to return that in the normal array. So what we can just do is we can use the spread operator, or we can just use array dot from and pass in the result. Okay, so let's check if this works. Okay, so that works, and if I submit, okay, so we are getting best time complexity, and space complexity is about 50%. Okay, so this is the solution for the problem intersection of two arrays. So let us now move ahead. So this is a problem where we need to calculate the third maximum number in a given array. Okay, so you see that this is an array, so we need to calculate which one is the number which is the third maximum. Okay, so if you see this array, the first maximum is this 3, okay, the second one is 2. Okay, note that there are also duplicates within this array, so we don't have to take into account of the duplicates. So we just need to calculate just the third maximum number. You see that 1 is the third maximum number, so 1 is the number, so we just need to return 1 at the end. Okay, since 1 is the third maximum. So how do we solve this? So what we could do is we can sort the array in the reverse order. Okay, so if I sort the array, it would be 3, 2, 2 and 1. Okay, so since we also need to account for the duplicates, so instead we can create a set. Okay, so set, as you know, does not include duplicates, so this 2 doesn't exist. Okay, so since this is a set, so it will store all unique elements, and we just need to return the third element within this given set. Okay, or the second index within this array. Okay, or the set which you call it. So that is 1. So 1 is the number which we return at the end. Okay, so you see that sort operation is not very cheap. Okay, so it takes an time complexity of O of n log n, so which we have to compromise a little bit on time complexity. So how can we make this better? Is there a way how can we achieve this particular problem in a O of n time complexity? So what we could do is we can create 3 variables. Okay, so that is for the first maximum number, second and the third. Okay, so first, second and third. Okay, so initially these 3 variables will be set to null. Okay, so this doesn't have any value in them, so we just loop across the given array one by one, and we just need to place them in these three variables. So what do I mean by that? So let's say for the first iteration, okay, where the value of I is 2, so initially all of this will be null. Okay, so this will be the first maximum number by default, right? So since all others are null, so this is the only number which is the maximum, so we set that value to 2. Okay, so first was null before, so now it is 2. Okay, so now we increment I. Okay, so this is a duplicate, right? So we need to account for the duplicates as well. So we need to check in any one of these variables, is the actual value of this I already present. So if it is already present, then we skip that particular iteration. So we increment I. So the value of I is 3. So now we need to compare that to the value of the first element. Okay, so that is 2, right? So 3 is greater than 2. So we need to update the value of the first variable. Okay, so I update this to 3. Okay, and now I need to make 2 the second highest number. Okay, so since 3 is a new competitor, so it took the first position, and we need to push the previous one which was already first, right? So we need to push that to the second. I hope that made sense. So let's increment I. Okay, so now we see if I is in the first, second, or the third position. So we compare I, the value of I, that is 1, if it is greater than the 3. Okay, so it is not greater, so then we again check if it is greater than 2. Okay, or the second index or the second variable that we created. So obviously 1 is not greater than 2, so obviously 1 stands at the third position. Okay, so at the end of the program, as we finish looping across all the elements, so we check what is the value within the third element. Okay, so we just need to return what is there in the third. Okay, so if it is null, then we need to return the second element. Okay, so that is 2. Okay, so in case this is null, right, so we need to return 2 over here if this doesn't exist, for example. Okay, so we have 2, 2 and 3, so we do not have a third maximum number, so we return the second one. Okay, the same, if second also doesn't exist, then we return the first maximum. Okay, so this is the solution for this problem, third maximum number. What is the time complexity involved in this operation? That is O of n. So we are just looping across all the elements in the array once. So we have reduced the time complexity, that is from O of n log n, while for the sorting operation to just O of n. Alright, and what is the space complexity? The space complexity is O of 1, since we are creating only 3 variables and not respective of the number of inputs within the array. So space complexity becomes O of 1. So let's see how can we solve this by code. So let's initialize the 3 variables. So I'm going to set first to null, and the same for the second and third as well. Alright, so once we do that, we run a for, let num of nums. Okay, so inside this loop we are going to first check if the number is already been there within this existing variables or not. Okay, which means that there is a duplicate and we want to skip that. So let's put an if, let's say num if that is equal to the first. Okay, and we check the same for the second and third as well. Okay, so if that is true, then we just want to skip the current iteration by just saying continue. Otherwise we want to make those if checks. Okay, so first we need to check if the first is null and if that num is greater than the first, right? So we just update those respective variables. Okay, so num is greater than first, then we just update the 3 variables. Okay, so first we need to make the number as first. So to update variables simultaneously, we can just use square brackets and just put in elements inside that. So first, second and third. Okay, and set that equivalent to the respective indexes where the variable needs to be updated. Okay, so we want to update the first to the num, okay, and second to the first, and third to the second. Else if second is null, or you can also use a not operator if you want, or the number is greater than second, then we enter this block and then do the updation. Okay, so let's update this time only the second and third, so we don't disturb the first variable. okay. So second and third to be equal to the num for the second, and the third becomes the second, okay. So let's do the same to check for the third condition. Else if the third is null or num is greater than third, then we update third to the num, okay. Okay, so this is a shorthand where you don't use brackets if it is all in one line. So finally we just return the value of third, okay. So we need to now check if third is null. So if we do not want to return null, okay. So if that is null, we want to return the second largest number. If that is also null, then we return the first one, okay. So let's return, let's first check if third exists, okay. So if it is a truthy value, or wait a second, it can also be 0, right? So let's just use null, okay. If that is null, then we return second, okay. So we also need to check if second is also null, okay. So let's also check that. If that is null, then we return first, okay. Else if second is not null, we return second, else we return the third largest number itself, like this. So this is confusing, let me make it clear. We first check if third is null, then we return second, okay. So before that we even check if second is null, okay, then we return first, okay. So if second is not null, then we return second, okay. So if third is also not null, then we return third itself, okay. So now let's run. So we are getting a wrong answer here. So the output is 1, but the expected is 2, okay. Of course we need to return 2 instead of 1. So we can just skip the second one and just try it once again, because I just saw the solution and saying it. So let's get rid of this second check, okay. So if third is null, return first, else return third itself. Let's run this and check, and that passes, okay. So I don't know what was the logic that was wrong over here, maybe my misinterpretation. So let's submit and check our performance. So we are getting good time complexity, but not good in space complexity, just as we are creating many variables over here. So this is the solution for the problem third max. So now let's move ahead. So this is a problem called sort array by parity, okay. So the problem states that we need to move all the even numbers to the start of the array and move all the odd numbers to the end of the array, okay. So this is a given set of numbers. So what the naive approach or brute force way of doing is that, so we check for every number if that is an odd number. So we create two variables, one is for the even and one is for the odd, okay, and check if every number, if it falls within the even or odd, okay. So 3 is odd, so we add to the 3 or the odd array. So then check 1, so that is also odd, and 2 and 4, that is even, right. So finally we merge these two arrays, okay. So we put all the even to the start of the array, so 2 and 4, and all the odd numbers within this odd array to the last, okay. So this is the solution which we need to return at the end. So what is the problem here? We are creating two additional data structures to store the even and odd, okay. So is there a way how can we modify the existing array itself so that we are not creating additional space? So how do we solve by that? So we can create two pointers, that is left and right, okay. So the left will be at the start of the array and the right pointer will be at the end of the array, which is pointing to the last element, okay. So what we need to now do here is we need to check if left, the value of left is even and the value of right is odd, okay. So in this case both of the conditions are not satisfying, so we swap the two elements, okay. So left is not even and right is not odd, okay. So we swap these two elements, so it would become 4, 1, 2 and 3, okay. So now you see that left is even and right is odd, okay. So if it is even, then we increment left, okay. So now we see that left is odd now, okay, but right is still odd, okay. So that should be even. So what we do is we shift the right pointer to the left, okay. So now we see that left is odd, okay, and right is even, okay. So if both the conditions are not satisfying, then we swap the two elements. So 1 becomes 2 and 2 becomes 1, okay. So swapping the two elements. So now we see that we have come at the end of the array where left and right are overlapping. So that's where we end the loop and we return the current state of this array. So that is 4, 2, 1 and 3, where we move all the even numbers to the left and all the odd numbers to the right, okay. So this is how we use a two-pointer approach to solve this particular problem. And what is the time complexity involved in this operation? That is O of n, since we are looping across the entire array just once, and space complexity is just O of 1, since we are not creating any additional data structure. So this is the problem. How can we solve the sort array by parity? So let us see how can we solve this by code. So let's initialize the two pointers. So let left equals 0 and let right equals nums.length minus 1. Okay, so we have initialized the two pointers. So now let's run a while loop while left is less than right. Okay, so we just keep doing the if checks. Let's now check if the nums at the left index is a even number. Okay, so if it is an even, then we increment left. Okay, so we are shifting the pointer forward. Okay, so if it is an odd number, so we shift the pointer at the right one step back. Okay, so that's what the logic we are applying here. So let's check if nums at left %2. Okay, so this will give us a reminder. So if we have a remainder, then it is a odd number, else it's an even. So let's %2 and check if that is equal to 0, which means it's even. Then we increment left. Okay, so we can just use the shorthand operator just by writing it in the one line and increment left. Okay, so let's put an else if nums at right, and now we check if that is an odd number. Okay, so we do %2 and check if that is not equal to 0, or we can also check if that is equal to 1. Okay, and we increment or we decrement right. Okay, if the number is odd on the left and even on the right, so we just want to swap those two elements. Okay, so let's put an else, which means that it didn't go through these conditions. Then we just set nums at left. Okay, so we just use again the shorthand for swapping variables using this square brackets, and interchange those two variables, nums at right and equals nums at right comma nums at left. Okay, so this swaps the two numbers, okay, within the respective variables, and finally we return nums, okay, after this while loop. So let's run. So that passes, and if I submit, let's see our performance. Okay, so the best in time complexity, but not the best in space, since we are creating two variables here, and yeah, that's why. So this is the solution for the problem sort array by parity. So now let's move ahead. So this is a problem called squares of sorted array, where the given array is already a sorted array. We just need to return the squares of all the elements within the given array. Okay, so what we could do is we can loop across every element within this array and find the square of that. Okay, so we square all of the elements. So this becomes 16, 1, 0, 9 and 100. Okay, so all we now need to do is just sort the complete array. So that would become 0, 1, 9, 16 and 100 if we sort this. Okay, so this is the solution. So as you know, this is not the efficient way of solving this. So since the sort operation is taking a time complexity of O of n log n, so the question is how can we make this better or solve this in a more efficient way. So to do that, we can create a results array which we need to return at the end, so which is the same length as the given nums array. Okay, so now we initialize 3 pointers, okay, this time. So one we can call this left at the start of the given array, and one is at the end of the array, we can call this right, and also we keep track of another index called I. Okay, so we can call that I, and now we take the squares of the left and right. Okay, so what is the square of left? So that is 16, and the square of right is 100. So now we see which one is greater, left or right. So obviously right is greater, so we add right to the results array. Okay, and the right has to be at the index of this current one. Okay, so that is at the last. So since I is at the pointing at the last element, right, so the index of this is 4, so we add that to the last. Okay, so this has to be sorted in the ascending order and not descending, so that is why we are setting I to the last element, and now we decrement I and R as well. Okay, so I is here and R, so now we take the square of R, so that is 9. Now this time left is greater than right, so now we add 16 to the current index, so that is 16 here, and now we increment left. I had to increment I, right? Since we also incremented left, we also need to decrement I, sorry. So now we check left and right, which one is greater. So right is greater, so we add the value of right, that is square of 3, 9, to the index of I, that is 9. Sorry, we decrement right. Okay, so since we added right, so we decrement that. So whichever the element which we are adding, so we increment or decrement. So if we are adding the value of left to the results array, then we increment left. So if we are adding the value of right, the square of that, to the array, then we decrement right. Okay, so irrespective of either left or right, so we keep decrementing I. Okay, so that we get to know where we need to place the particular element within this results array. Okay, so now we decrement I. Okay, so sorry, this is looking a bit confusing. So now we compare left and right, which one is greater. So the square of left, that is 1, is greater than the value of right, so that is 0. So we add left to this and we increment left. Okay, so left and right can both be equal. Okay, and finally we decrement I, so I is at the last index now, so obviously left and right both are equal, so we just add the value itself to the start. Okay, so sorry, this will be 1, and so now we see that our array is being sorted, and yeah, so that is 0, 1, 9, 16 and 100. So this is the expected result, and which we need to return at the end of our program. Okay, so the biggest benefit of this is we are not creating any kind of sort operation that takes a complexity of O of n log n. So the time complexity is O of n, and space complexity is O of n as well. Okay, so the results array is same as the length of the nums array. Okay, so in the previous one we didn't have to compromise on the space, but here we have to do so in order to save the time complexity. Okay, so in any one, of course, as I said, we have to compromise a little bit, so based on the requirements of your program. Okay, so this is a problem, squares of sorted array. So let us see how can we solve this by code. So let's initialize the results array. Okay, and I'm going to use a array constructor and saying that these many elements should be in the array. Okay, and set that number to the length of the nums array, so nums.length. Okay, so this will create an empty array with the length of this nums array, and let's also initialize the 3 pointers. One is for the left, right and the index. Right, so now let's run a while loop while left is less than or equal to right. Okay, so they both can be equal as well. So now we calculate the left square and right square. Okay, so now we also calculate the right square. Alright, so once they are done, now we just need to do the checks over here. So to check if the left square is greater than right square, and then we increment left and do the same and decrement right for the right square. Okay, so if that is lesser, so let's put an if left square is greater than right square, then we just want to add that to the results array at that particular index. Okay, so this index over here, so result and set that to left square. If right square is greater than left square, so we put that in the else case, then we set the result at the particular index to the right square. Okay, so finally we we decrement index. Okay, so for any of these cases, So once we do that, once we come out of this while loop, we return the results array. Alright, so everything seems good. So let's now run the file. Sorry, this should be just result, and if I run this again, sorry, I forgot to increment left and decrement right. Okay, so left plus plus and right minus minus. So sometimes when I'm talking and typing, I just forget some steps as well. Okay, so let's run this again. So that passes, and if I try to submit, so we are getting good time and space complexities. All right, so this is a solution for the problem sorted squares. Okay, so let's move ahead. So this is a problem called merge sorted arrays, okay, where you will be given two arrays along with the number of elements or length of the array. So we just need to sort them into one array, so that is nums1 array, and then all the elements inside that should be sorted. Okay, so basically we have nums2 array, right? So we just need to merge them into nums1 array itself, and then that all the elements should be sorted, so without creating any additional data structure, okay, or any additional arrays. Okay, so how do we solve this? So the brute force way of solving this problem is by merging the nums2 array into nums1 array itself, and by just using the sort operation that takes the time complexity of O of log n, right? Sorry, n log n. So if I just sort this, so number of elements will become from 6 to 9 since I'm adding them. So if I just use the sort operation and filter all the zeros out, so that would be sorted. Okay, so the problem in this is the time complexity, which is taking a time complexity of O of n log n. Okay, so which is not optimal, not the best solution. So how can we make this better? How can we solve this in the most optimal way? So what we can do is, we are given two numbers length, right? So that is m and n. So where the number of elements from numbers 1 starts with m is equal to 3. Okay, so we need to consider only these three elements are the right candidates to be sorted, right? So and also for m2, n is equal to 3. So these are the sort candidates. All right, so we just need to consider only this and neglect all the other elements, and then sort them into the same array. Okay, so that is nums1 array itself. Okay, so we have 6 elements, so we just add these 3 elements and replace these zeros with that. Okay, so for this, what we can do is we can we can initialize 2 pointers. One is at m, at the mth number, so that is over here, let's say I, and we can point the second pointer of the nums2 array to the nth element, so that is 3, that is the third number, and then from there on we can just do the comparison between pointers, right? So now we check the value of I and the value of j, which one is greater. Okay, so the one that is greater, we add that to the end of the array. Okay, so how do we calculate the pointer at the end of the array? So it's very simple, we just add m plus n, so the value is 6, right? So the sixth element will be, let's say we can call this let's say p, and then we update this element, so this will be the pointer. So now we check value of I, that is 3, value of j is 6, which one is greater? So 6 is greater, right? So we replace the previous value of p to the value 6 like this. Okay, and then we decrement j and not decrement I. Since we have already added 6, we decrement j, and then we check which one is greater. So again 5 is greater than 3, then we again we need to decrement p as well along with j, and then we update this value to 5. So I hope you got the point. We just compare two elements, which one is greater, we add that to we update the value, and then we decrement one number from that. So now we decrement j, and now check I and j, which one is greater. So this time I is greater, so we update the value of p, so this time it's here, to number 3. Okay, so again we decrement p and decrement I as well. Okay, so now we check 2 and 2, which one is greater, so we can consider any value. So we can, let's say consider j value and update this 3 to 2. Okay, or we can just do the same for I also. So let's say I, since we have elements from nums1, and then decrement I and decrement p. Now we see 1 and 2, which one is greater? 2 is greater, right? So we update p to 2, so p is already 2, so we don't have to do that, and then we decrement j, so j is out of range now. So whatever the elements we have from number the I, then we just add that to the array itself. Okay, so now we decrement p, and I and p are having the same value, so we just leave it as it is. So we have come at the end of the array. So at the end you see that the given nums1 array is sorted. Okay, so by doing the comparisons, which one is greater, we add them to the p value and then decrement 1 from there. Okay, so that's the idea behind this. Okay, so what is the time complexity involved? So that is O of n, since we are looping all the elements in the array once. Okay, so that's the biggest performance improvement from O of n log n to just O of n. So this is the time complexity. And what is the space complexity? Are we creating any additional data structure? No, right? So the space complexity is just O of 1. So this is a problem called merge sorted arrays. Let's see how can we solve this by code. So let's initialize the 2 pointers. So I'm going to call this p1 for pointer 1, and that needs to point at the m value, that is 3. Okay, so we need to point at the third number, so we can just subtract 1 to make it 0 based. So we can say m minus 1, and let's do the same for the pointer 2 as well. So we can replace this with n minus 1 and give this p2, and also let's set the final pointer which has to update the value to the last element of this nums1. So let us say let p equals stands for pointer, and let's update that to m plus n and then minus 1. Okay, so this should come here, minus 1. Alright, so once we do that, we can now run a while loop as long as p2 is greater than 0, which means that p is in range. So now we need to check if nums1 is greater or nums2 is greater. Okay, so we can just point nums1 at pointer 1 if that is greater than nums2 at pointer 2. Alright, so then we just update the nums1 at p this time. Okay, so it's just p and not p1 or p2, and we update that value to nums1 at p1. Okay, so since this is greater than nums2, so let's update that, nums1. So now we decrement p1. Okay, if this is not the case, so if p2 is greater than p1, then we just do the reverse. Okay, so we set nums1 at p. Okay, so and that value is now nums2 at p2. Okay, so and then we decrement p2. Okay, so finally after this, irrespective of any of these conditions, we want to decrement p, right? So let's decrement p, and let's we don't have to return anything, so this will just modify the nums1 array. So okay, so let's run this, and also we need to make a check right over here. So if p2 is out of range, then we want to keep the p1 elements there itself. So we can just put another condition here. So if p1 greater than or equal to 0, and this condition over here. Okay, so let's run this, and this should be greater than or equal to 0. So we are checking even for the current element, right? So let's run this, and that passes. Okay, so let's see our performance. So we are getting best time complexity and space complexity since we are creating these variables. So we are getting about 65%. So this is the solution for the problem merge sorted array. So now let's move ahead. So this is a problem called find difference of two arrays. Okay, so you'll be given two arrays over here, and we need to calculate the difference between them. So what do I mean by calculating difference? So basically you need to return an array of arrays consisting of num1s and num2s. So basically if we find an element that is common from num1 and num2, so we need to delete that from both the arrays, and we just need to return an array of nums1 and nums2. So basically it would become like this. So nums1, so you see that 2 is present in both nums1 and nums2. So we need to just return 1, 3, and then another array of 2 and 6, 4 and 6. Okay, so this is an array which we need to return at the end. I hope you got the problem statement. So the first array contains all the distinct integers in nums1 that are not in nums2. Okay, so the second array consists of all the distinct integers in nums2 that are not in nums1. Okay, so that's basically the problem. So what we can do is we can basically create two arrays, one's for nums1 and nums2. So we can call this result1 and result2. So we can just create two arrays over here like this. So we need to check one by one within nums1 to nums2. So if 1 is present in nums2 or not. So if it is not present, we add that. Again we check 2, yes 2 is present, so we do not add that. then we check 3 is present or no. So 3 is not there, so we can add 3. So the same we can do from nums2 to nums1 as well. So if that 2 is there, then 4 is not there, then 6. So 6 is not present in nums1, so we add that as well. Okay, so then finally we merge this into one array of arrays. So basically 1, 3 and 4, 6. So basically this the same thing over here. So what is the problem in this? We will be having a time complexity of O of, let's say if n is the number of elements from nums1 and nums2 is m, so that will become n into m. So basically that is O of n square. So basically we are comparing elements that were previously also compared, right? So that's not the most efficient solution, and the space complexity is like the worst case. It could be there will be no intersection, so it would be nums1 plus nums2 itself, O of n plus m. So this is the space complexity. So how can we solve this in a better way? So we can convert the nums1 and nums2 to a set. So we can just use the set data structure in JavaScript. So basically that will hold unique elements, okay, and suppose there are duplicate elements, so that will get converted to an array of unique elements. So there is no point in checking duplicate elements as well, right? So the reason why we are using set is it has a fast lookup, right? So if I don't have to loop across every single element to if it is actually existing, okay? So if I convert to a set, I use the has method to access that if it actually there. So the lookup is just O of 1. So if I use an array, so the lookup is O of n. So that's why we converted this to a set. So what we can now do is we can filter out elements. So basically from nums1 we filter those elements that are not present in nums2. So basically it will find the elements in nums1 that are not in nums2 and vice versa, okay? So we can use the filter method and get this, okay? And once we filter out, we can just merge these two sets and return a single array, okay? So an array of these two elements, so nums1 and nums2. So basically these two arrays like this. So this will contain the nums1 and nums2 which are actually filtered, okay? And also we need to convert the set back to an array, okay? So that's we cannot return a set, by the way. So what is the time complexity involved by doing this? So the time complexity is just O of n plus m. So the worst case is that we are going through each and every element from both the nums array once, right? So that would just become n plus m, whereas in the brute force way we are doing the nested comparisons. So that is why that used to take a time complexity of O of n times m. So here it is n plus m, and the space complexity still remains O of n plus m as well, okay? So this is the time and space complexity. Let us see how can we solve this by code. So let's convert the two numbers to a set. So I can just call the set1 and use the set constructor and passing in num1, okay? So I can just do the same for num2 as well by replacing this with 2. Alright, so now let's create a result 1 for the set1, and then finally we can just merge them, right? So result 1, and we can just use the array dot from. So basically to convert the set1 back to an array, so we pass in set1, and then we can just filter all those that are not in set2, okay? So we can set filter, and we can just say for every number we just want to set a condition where the set2 dot has, so this is a fast lookup, that's why we are using set, and then we pass in num, and this has to be a falsy value, so we can just use an exclamation mark. So basically if this condition fails, then we just want to return that. So we can just do the same for array 2 as well. So let's duplicate this and change this to result 2, and array dot from set 2, and we just want to filter that from set 1, okay? Finally we just return the merged result 1 and result 2 arrays. So return, so result 1 and result 2. Alright, so this is basically an array of arrays just as we are seeing over here. So now if I give this a run, and of course this has to be nums and not just num, my bad, sorry. So that passes, and let's see our performance. Okay, so best in time complexity but not that much in space. So as I told, if you want to like get a slightly better solution in terms of time complexity, we use certain space, okay, to solve a given problem. So that is the solution for the problem. What is that? Find the difference of two arrays. So now let's move ahead. So this is a problem called binary search. Okay, so basically you'll be given a nums array which will be actually sorted. Okay, so that's true, and we just need to find that particular element that we need to search for. Okay, and the number to be searched, let's say 9. So if I got the target, so the target value is 9, so we need to search within this nums array, and we need to perform this in a time complexity of O of log n. Okay, so the time complexity should be O of log n, and this is a condition which is mentioned in the LeetCode problem. So we can also do the manual search as well, that takes probably the time complexity of O of n. So we need to make this better. So we need to take advantage of this array being sorted. Okay, so as I told, if the array is sorted and we want to search something, we can use a binary search. So as I explained you in the time and space complexity video, where we need to check the mid value of 9, so where it is actually, so if it is on the left side or right side, so we calculate the mid element and check if that is lesser than or greater than the target value. So if it is lesser than, we eliminate all the other values and only consider that sub array. So over here what we can do is we can initialize 2 pointers, let's say I, and another pointer to the last element of the array, that is j, and we need to calculate what is the mid element. So the mid is like over here, so in between 3 and 5. So we take the floor value and we consider 3 over here. Okay, so let's call this k, and we need to check if this k is lesser than or greater than the target. So if it is lesser than the target, then we eliminate these values on the right side. So if it is greater than the target, then we eliminate values on the left. Okay, so in this case 9 is greater than 3, right? So we eliminate all the values that are on the left. So the array now becomes, so we need to make the value of k to the value of I. Okay, so this is the array that we are considering. So 3, 5, 9 and 12. Again we keep doing the same thing. So what is the mid element from I and j? So that is between 5 and 9. We take the floor of that is 5. So we keep k at 5, and we need to check if k, that is 5, is greater than or lesser than 9. So it is lesser than 9. So what we do is we update the value of I to k this time. Okay, so basically we eliminate all the left side values, and now we again check for the mid element, that is 9 over here, and we set k over here. Now you see that the value of k is equal to the target. Okay, so now we just need to return the index of this 9 over here. Okay, so that is 0, 1, 2, 3 and 4. So 4 is the index which we need to return at the end of our program. So I hope you got the idea. We are eliminating almost half of the array by checking the mid value of that. So if it is greater than or lesser than the target. It's similar to your telephone directory. If you are searching for a name, you don't have to search from the start. You just go to the letter and then search from there onwards. Okay, so as simple as that. Let's go ahead and see how can we solve this by code. Let's start by initializing the 2 pointers. So I'm just going to call this left, and I'm going to set this to 0, and I'm just going to set right to the last element from our nums array. So let's say array dot, or you can say nums dot length minus 1, since this is 0 based, so we can call this right. And now we can just get started with our while loop while iterating over all the numbers in our array. So we can put a condition here, while left is less than or equal to right. Okay, so basically the 2 pointers, like if they intersect each other, we just want to quit the while loop, and then we just want to return whatever the value we get. Okay, let's now fetch the mid element. So I'm just going to call this mid, and I'm going to set this to the floor value by dividing that by 2 and taking the floor value of that. So we can just say math dot floor, and here we can just pass in the left plus right divided by 2, basically the 2 indices. So left plus right, and divide that whole by 2, and now we can check if the mid element is the number which we are trying to find. Okay, so basically this target. So we can just say if the array at mid is equal to the target, then we just want to return the mid. Okay, so if that's not the case, let's check if the target is less than or greater than the mid value. So else if nums at mid um, num set mid, if that is less than the target, then we just want to update the left pointer. Okay, so we just say left mid plus 1. So basically we just want to start from the mid wherever we had taken the mid value of that, so we keep that left pointer over there. So if that's not the case, then it should be greater than the target, so we can handle that within the else. So here we just want to update the right pointer. Okay, so we just don't want to subtract one, sorry, we just don't want to add one, we just want to subtract one, since right is we are at the last element from our nums, so we just want to keep on subtracting that. Okay, so now we can just finally return -1 if we do not find any value. Okay, so once our while loop is over, so if we didn't find the target, then we just return -1. Okay, so let's run, that passes. Okay, so let's, and that's looking good. Okay, so let's now move on to the next problem. So we have solved about 20 questions related to arrays, which are easy in LeetCode. Okay, so I have a bonus question for you, which actually appeared for me while giving my interviews. It was for the IBM company, which I actually failed to solve that. So I'm just going to pick up the same question, and I see that it was a little bit common for other candidates as well. So I just thought I'll just make a video on that as well. So if you have come till here, this is like a bonus for you. Let's see what is the problem actually about. So the problem is to find the mix of an array. So what is the meaning of mix? So basically it stands for minimum excluded value. Okay, so what do we mean by calculating the mix of an array? So you will be given an array over here and a value called x over here. So what we need to now do is we need to modify exactly one element within the array by adding the value of x to it, and our goal is to maximize the minimum excluded value. So basically the mix of the modified array. So modified array is the one which I add to the particular array and then calculate what is the minimum excluded value for that. So now if I add 3 to the index 1, so basically which is having the value 1, so this would become 4, right? So the modified array would become 0, 4, 2, 1 and 3. So now we need to check what is the minimum value that I can add to this array. Okay, so this is an array. So I have all the elements. So we have 0, 1, 2, 3 and 4. So what is the minimum one? 5, right? So 5 is the minimum one. So we need to return this 5 over here. Okay, so I hope you understood. So the same thing if I add to, let's say, the value 0, the first index basically. So this would become, let me just erase this. So that would become 3, 1, 2, 1 and 3. So basically 0 plus 3 is 3, right? So now what is the minimum excluded value? That is 0. So you see that 0 is not there within this array. So I need to return 0 here, but we need to check which one is greater. We need to check for all possible values. So I add 3 to 0, 1, 2, 1, 3 and then check what is the minimum, basically the max value. So over here in this case it is 0. So in our previous case it was 5, and we need to check for other 3 values as well. Basically we need to just keep a track of a variable that is the maximum value, and then we need to check which one is maximum and return that value. So in this case it is 5, so we return 5 over here. So I hope this is clear. Let's see this in code now. So I've just created a function called find max mix, which will take in the array of numbers and the x value. So the first step is to calculate the mix for this given array, so without any modification. So we can just store within a let variable, and we can call this max mix, because later we are going to update this once we modify this array. So we can just create a helper function called as calculate mix, and then we pass in the array of numbers. So initially, okay, later once we keep on adding this number to each and every element to this array, so we need to recalculate the mix and update this value. Okay, so we can just create that function here called as calculate mix, and this will take in the array itself. And here we just need to we can just create a set to hold all the unique values for the array. Okay, so we can call this num set, and we can just set this to a new set and then pass in the array. So this will contain all the unique elements within the array, and also we can access properties like to check if the element is there within this set, okay, which actually does fast lookup. So let let's store a variable called mix and set that to 0. So we can just run a while loop, and then here we can set that if numset dot has, and then pass in the mix. Okay, so we just want to keep on increasing the mix, so we increment the mix and then we return the mix after the loop. So what we are doing here is we are initializing a value of mix to 0. So as long as it has a value within the given set, so it keeps incrementing the value. The moment it doesn't find that, it is going to return that. So that is the the minimum excluded value. Okay, so this is the helper function. So we will be using this once we modify this array as well. So now let us loop the given set of numbers by adding this x value to each and every number that we have, and then recalculate the mix. Okay, so if we find that the mix is greater than the value that we calculated for the original set of numbers, then we update that. Okay, so let's create a for, and let's say let I equals 0, I less than array dot length I plus plus. And now we just need to create a copy of the array, so we do not want to mutate the original array. So let's create a modified array and set that to we can just use a spread operator, or you can use array dot slice as well. So this will create a copy of the array. So now we just want to add the value of x to the ith iteration. So modified array at I plus equals x, and then now we just need to calculate the new mix, right? So we have modified the array, so let us create a new mix and set that equal to again the function that we created, calculate mix, the helper one, and then pass in the modified array. Okay, so this will calculate the new mix. So now we just need to update the value which one is greater. So we can just use the math.max function to calculate the maximum of two numbers. So we can just update the max mix and set that to math dot max and pass in max mix and then the new mix. Okay, so finally we just return the max mix. Alright, so this is the solution for the problem find max mix. So let's run this file. So for this example, where I pass in the value 0, 1, 2, 1, 3, just as I explained you on the whiteboard, so we get the value 5 over here. So 5 is the minimum excluded value. Okay, so if I add to this given set of numbers, so that is 3, so I get 5 as a minimum one. So if I add another number, let's say 5, so this time I should get 6. So if I rerun this, I get 6. Okay, and if I just try this once again with 6, I should still get 5. Okay, so that's working fine. So this is the solution for the problem max mix. So this is the bonus problem that we solved, that is to calculate max mix, which I found during my interviews, and it would help you as well. So if you encounter this in your interviews as well. So this is all for the series about arrays, particularly in easy questions. So if you have any questions or any doubts related to this particular video, you can just let me know in the comments. In the next video, we will be solving problems related to strings, okay, which are easy level. Okay, so that's it for this video. I hope you liked it. So if you come till here, congratulations. I really appreciate you watching my content. So if you like this video, please give it a like and subscribe to this channel for some more valuable content just like this. So that's it for this video, guys. Thank you so much. I'll see you guys in the next video.